Hello everyone, welcome to our channel Assemble to Learn. Friends, this is the part 5 of OAVS PGT Physics previous year 2023 questions with solutions. In last video we have completed question number 40 and in this video we will start from question number 41. Okay, let's start. Question number 41. During a magic show, a magician makes a glass lens of refractive index n equal to 1.47 disappear through a liquid. The refractive index of the liquid should be. So, according to question, we have to calculate the refractive index of the liquid. In a magic show, magician makes a glass lens of refractive index n equal to 1.47 which disappears through a liquid. Suppose this is our liquid and here a glass lens is inside the liquid and it disappears, and given n of lens, refractive index of lens is 1.47. If the lens is disappear, that means the lens is invisible over here. Lens is invisible, and it will happen if the lens behave like a plane sheet or plane mirror. Plane sheet or plane mirror. Okay, then what is the focal length of the plane mirror? For plane mirror, focal length is infinite, and we use the lens maker formula, that is f1 by f is equal to mu refractive index. Here n is written, so n refractive index of lens upon refractive index of medium minus 1 whole into 1 by r1 minus 1 by r2. Okay, then f is infinite, that means 1 by f is equal to 0, and refractive index lens by refractive index of medium, here liquid, minus 1 multiplied with 1 by r1 minus 1 by r2. Here, as r1 cannot be equal to r2, 1 by r1 minus 1 by r2 is not equal to 0. So, what will be equal to 0? That is refractive index of lens upon refractive index of liquid minus 1 must be equal to 0. That implies refractive index of lens upon refractive index of liquid is equal to 1. Okay, and so our conclusion is refractive index of lens is equal to refractive index of liquid. So the question over here is the refractive index of the liquid should be, and it should be equal to refractive index of lens, right? So option 4, that is equal to 1.47 is the correct answer. Then next question, question number 42. This is a methodology question, introducing pictures and 3D models. What pictures and 3D models in the curriculum is a what kind of teaching aid? Audio, visual, reading, writing. Obviously, pictures and 3D models are visual kind of teaching aid. Question number 43. A filament emits electron when the potential difference of 81 volt is applied across it. The wavelength associated with the emitted electron is. Filament emits electron and potential difference is V is given as 81 volt. Wavelength associated with the emitted electron is wavelength associated lambda is equal to h by p. Here p is the momentum and momentum is related to kinetic energy as h by 2m kinetic energy under root 2m ke. Here electron is given, so we have to relate this momentum part with potential difference. As we know, kinetic energy is equal to work. Kinetic energy is equal to work done, and work done is equal to QV, charge into potential difference. Here electron is the charge, so EV. We can write kinetic energy is equal to EV. So our lambda becomes h by 2m EV under root 2m EV. Here h is Planck's constant, that is value is 6.626 into 10 to the power minus 34 joule second. H, then m, mass of electron 9.1 into 10 to the power minus 31 kg. Then charge of electron is equal to 1.6 into 10 to the power minus 19 coulomb, and V is given as 81. By putting all these values, we can find the value of lambda. But there is also a formula. If we calculate separately all the values, then for electron only, for electron lambda is given as 12.27 by under root V, and lambda in angstrom. Okay, approximately 12.27 divided by under root V, that is potential difference. So if we put the value of V over here, lambda is equal to 12.27 by under root 81, that implies 12.27 by 9, and it will be 1.36 angstrom. So here answer is option 1, 1.36 angstrom. Now question number 44. The internal reflection of light occurs when light travels from an optically active medium to optically inactive, active to inactive, option 2 rarer to denser medium, option 3 inactive to optically active, denser to rarer. Here total internal reflection of light occurs when the light travels from denser to rarer medium. Okay, rarer to denser or denser to rarer, that is internal reflection, total internal reflection occurs only when the light travels from denser to rarer medium. So option 4 is the correct one, denser to rarer medium. A test that is designed to provide a measure of performance that is compared with a pre-specified level of accomplishment is known as DES test. Designed to provide a measure of performance that is compared with a pre-specified level. Norm reference, prognostic reference, standardized reference, criterion reference. As it is compared with a pre-specified level, there is some criteria. So according to answer, it should be criterion reference test. Okay. 46, question number 46. Dash of the concept of the same level in two consecutive classes lacks the quality of dash organization. Which of the concept of the same level in two consecutive classes lacks the quality of which organization? Okay, options are repetition, parallel, repetition vertical, relevance parallel, relevance vertical. Okay, option 2 is correct, as repetition vertical means here repetition of concepts of same level in two consecutive classes lacks the quality of vertical organization. There should not be repetition of same type of concept in two consecutive classes, because it leads to repetition of concept same level in two consecutive classes does not lead to vertical organization, lacks the quality of vertical organization. Okay. Then question number 47. If 20 gram of ice at 0 degrees Celsius is mixed with 20 gram of water at 50 degrees Celsius, then what will be the final temperature of the mixture? Okay, 20 gram of ice 0 degrees Celsius mixed with 20 gram of water at 50 degrees Celsius. Then there is a mixture. So what will be the final temperature of the mixture? We have to calculate the final temperature of the mixture using concept of calorimetry or heat release equal to heat gained. Concept of heat lost is equal to heat gained. We can solve this. So here the ice, 20 gram of ice at 0 degrees Celsius come to first 20 gram of ice is at 0 degrees Celsius. It will require heat. It require heat to become 20 gram of water, ice to water. For conversion from ice to water, it will require heat. So 20 gram of water at 0 degree Celsius. For this, heat required is equal to Q1. Let's suppose Q1 is equal to ml. L is latent heat and m is mass. So mass is given as 20 and latent heat of ice, for ice latent heat is 80 calorie per gram. So 20 gram into 80 calorie per gram, Q is equal to 1600 calorie. Okay, heat required is to become 20 gram of water at 0 degree Celsius, 1600 calorie heat is required. Now when 20 gram of water is at 50 degrees Celsius, it release heat to become 20 gram of water at 0 degrees Celsius. Okay, 20 gram of water at 50 degrees Celsius will convert to 20 gram of water at 0 degrees Celsius. For this, heat released, and heat released is ms delta theta, or the and where S is specific heat, let Q2 is that heat released, and this is equal to ms delta theta. M is the mass, 20, S is the specific heat of water, that is 1 calorie per gram degree Celsius. So 20 into value of S is 1 into delta theta 50 minus 0. So 50 So 20 into 1 into 50, that is equal to 1000 calorie. So here what happened, for melting heat required is 1600 calorie, but during the conversion of water at 50 degrees Celsius to water at 0 degrees Celsius, heat released is only 1000 calorie. As heat released is less than the heat required, so the temperature of the mixture is the temperature of final temperature of mixture is equal to 0 degree. Okay. The ice doesn't gain any temperature greater than 0 degree. So the final temperature of the mixture is equal to 0 degree Celsius. That is option 2 is the correct one, because 1000 calorie is less than 1600 calorie. Question number 48. Consider a book at rest on a horizontal surface. It is subjected to what external forces? Okay, number. How many number of external forces? 3, 2, 1, 4. Consider a book. Okay, suppose this is the book at rest on a horizontal surface. This is our horizontal surface. It is subjected to what external forces? There is no external forces. One force is there, that is normal reaction in upward direction, and in downward direction self weight mg is there. Okay, so we can say it is subjected to two external forces. Question number 49. Consider the size of a nucleus to be about 10 to the power minus 14 meter, and it is scaled up to size of a tip of a pin to around 10 to the power minus 4 meter. After scaling up, the size of an atom will be. So what is given? Size of a nucleus to be about 10 to the power minus 14 meter. So let's say actual size of nucleus is 10 to the power minus 14 meter. It is scaled up to the size of a tip of a pin to around 10 to the power minus 4 meter. Means apparent size is 10 to the power minus 4 meter. Scaled means it is magnified. Okay, so we have a formula: magnification m is equal to apparent size by actual size. So m is equal to 10 to the power minus 4 divided by 10 to the power minus 14, and it will become 10 to the power 10. Magnification is 10 to the power 10. Now after scaling up, question is after scaling up size of an atom. Here size of nucleus is given, we have to calculate size of an atom. Means apparent size. As we know, actual size of atom is 10 to the power minus 10 meter, and we have to calculate apparent size, and we know the magnification, right? So putting the above formula, apparent size of atom is equal to magnification into actual size, and magnification is 10 to the power 10, actual size is 10 to the power minus 10, so it will become 1 meter. Okay, 10 to the power 10 multiplied with 10 to the power minus 10, and it is 1. So after scaling up, the size of an atom will be 1 meter, and this is option 3 is the correct one. Okay, now question number 50. A good teaching learning process takes place in a classroom only when what happens? Good teaching learning process takes place in a classroom only when what happens? Good understanding happens, an effective classroom communication happens, no communication, communication gap. No communication gap is also not correct. Good understanding is okay, and effective classroom communication is. This is the best option for question number 50. A good teaching learning process takes place in a classroom only when an effective classroom communication happens. Okay, this was the last question for today. Thank you for watching. Please do like, share and subscribe my channel.